So welcome to this how-to video that will show you how to work with the Omics skin in the SIMCA software and notably its analysis wizard. If you don't see the Omics skin, you have to click on the View tab and there select the Omics skin instead of the default skin. When you select the Omics skin, the shape of the Home tab will change, and on the Home tab we have put buttons that indicate a certain workflow, and we have also grouped very useful tools nearby each other. In an earlier recording I showed you how to import an Omics dataset into SIMCA and how to create an Omics project. The dataset that we are using here comes from the tutorial exercise called Poplar. Inside the dataset we have a class identifier that helps SIMCA to understand which observations belong to the two classes. We have a wild type comprising 10 samples and we have a treatment group comprising 9 samples. And we will now analyze this data table using the analysis wizard. We have a total of 78 variables. The analysis wizard is launched here and it is there to help us create a model or two models to overview the data and if possible also to separate the groups and find out what are the best discriminatory variables among the 78 variables in the data set. So when clicking on the analysis wizard button, the first stage is that we have to define the work set. Where do we pull the data from and what sort of data do we have? There are 5 pre-configured types of data. In this case we are using mass spectrometry, and each of these 5 entries then come with different pre-processings defined regarding, for instance, Pareto scaling or centering only and so on and so forth. Then what we have to do is to tell what do we want to accomplish, what sort of models do we want to calculate using the analysis wizard. One type of model is to work on the raw data and use principal component analysis to see and to get an overview of the data to see if we have indications of groups or outliers. If you're not familiar with what principal component analysis is, I refer you to watch the how-to video on principal component analysis. A complementary model that can be calculated is a model going for the two-group comparison. We will compare the wild type and the treatment group, and that model will be an OPLS DA model, and similarly here I refer to the how-to video on OPLS DA to get the details. We then have to define the groups, and we are using the group ID, which is in this case the class ID. We have to tell SIMCA which is the reference group, and the reference group, as we indicate here in the explanatory text, is a group that holds the observations that serve as a basis for the comparison. It could be control samples, wild type, healthy samples, or maybe untreated samples. In this case it is the wild type. The alternative group, that is the group which we will be comparing with the wild type, and this is in this case called 2B. So once we have done that initial assignment, we can click next and proceed in the analysis wizard. The next page in the analysis wizard is there to help us get an overview of the data. In the right hand part we see 19 bars because we have 19 observations, and the coloring is according to the class ID. So the green color throughout the analysis wizard, that is the wild type, and the blue color is the treatment group. In the left hand part we see all variables listed as bars. I can then click on one of those, and then in the right hand part I now see 19 bars. So these are then 19 bars from this particular variable. This stage of the analysis wizard has an exclude, include functionality depending on which variables you are selecting and what you want to do with them. Optionally, you may also open a transform dialog to change transformations of variables. For instance, you could consider the logarithmic transformation, but that one is beyond the scope of this little recording. If you're happy with what you see here, you don't find any obvious candidates for being deleted and so on, then we click next and proceed to the first model, which is the principal component analysis model. We can see here in the lower left-hand part that the PCA model has 5 principal components, and together collectively they account for more than 85% of the explained variance. The coloring again is in accordance with the two classes. The green color is the wild type and the blue color is the treated group. The ambition here with the score plot is to see if we have indications for groups, if we have outliers, and we can also then change which principal components are plotted by using these navigation tools up here, these drop-down arrows. So now I'm plotting component 3 versus component 1, and I can plot component 2 versus component 3 and so on and so forth. In the complementary plot to the score plot, we see the distance to model, and the distance to model plot has a control limit represented by the red dashed line. This is the critical distance at the 0.05 level. So if you have 20 observations, we have 19 in this case, but 1 in 20 should be above the line because of natural reasons in this test. What we're looking for here are observations which have a d mod x severely exceeding the critical distance by a factor of 3 or 4 or 5. In this case, there are no worryingly high residuals. If we want to, we can double click on a specific bar to open up the contributions and compare this sample to the average. And whenever there is a positive bar, it means that we have a higher than expected signal in the residual for this one, and so on. In this case, there are no significant outliers, so we will move on and use all 19 observations in the model. What is interesting to see that already in the PCA model, there tends to be a separation between the two classes, and that sort of indication of class separation we will examine more carefully in the next stage using the discriminant analysis model. So by clicking next here, we move on to the OPLSDA score plot, which we can see now has positioned the wild type to the left and the treated group to the right in the score plot. In the lower left-hand corner, we have more details on the OPLSDA model. We can see that it is a 2-component model. It has 1 predictive and 1 orthogonal component. The R-square of the model is 0.87 and the predictivity as estimated using cross-validation is 0.645. We have some results also reported here that comes from surrounding tools. The R-square and Q-square from the response permutation test is listed here, as is the p-value from the CV ANOVA test. And what the CV ANOVA test is and how response permutation test is working, that is part of other how-to videos. Since in this case we see no outliers in the model and we have a clear division of the samples, we can proceed in the analysis wizard to try to identify which are the drivers, which among the variables are the drivers accomplishing this separation between the wild type and the treatment group. Then, on the next stage, we try to identify the discriminating parameters using the S-plot. We also have, complementary to this plot, a quality indicator called the ROC plot. I will start by talking about the ROC plot. ROC is short for Receiver Operating Characteristic. The ROC plot is a visualization of the performance of a binary classifier. And it has on the x-axis the false positive rate and on the y-axis the true positive rate. And for a perfect classifier, you would find a curve that is arcing towards the top left corner at 0% or 0 false positive rate and 1 true positive rate. Formulated differently, you could also say that the arcing is in the corner where you have 100% sensitivity and 100% specificity. If you have a random classifier that perform on average, then the line, the curve, would align with the dotted 1, 1 line. In addition to the shape of the rock plot, you also have a quantitative measurement that is called AUC, the area under the curve. And for a perfect classifier that is arcing up here in the top left-hand corner, the area under the curve is 1.0. Conversely, for a random classifier, you would expect an area under the curve being 0.5. So enough about the rock plot. We now move on to the S-plot. The S-plot is created by plotting the loading of the predictive component together with the correlation scaled version of itself. It is called the S-plot because in many cases the variable points pattern an S. And those variables that are far out on the wings of the S in the upper right-hand part and the lower left-hand part are the strongest discriminators. You can here work with cutoffs just to help you to select different variables to zoom in on the most meaningful ones. Once you have selected the best or strongest discriminating parameters, you can also overview their descriptive statistics by clicking on this button, and then the analysis wizard will open up a list containing 8 univariate statistical indices for the variables that are currently highlighted, so you can resolve the information in the raw data. If you have no highlights in the plot, the descriptive statistics will list all this information for all variables in the dataset, in this case all the 78 parameters. If you have selected a certain variable, you can also click on it, and then a complementary dot plot is open up. The dot plot is like a histogram but resolved into dots and then colored according to the two classes. So going back to the initial highlight, these are the best discriminators to help you separate the wild type from the upregulated group. At the end of the analysis wizard, provided you have checked the box create report, when you click the finish button and exit the analysis wizard, a report is created automatically based on a template that is shipped with SIMCA and a template that you can modify the content in. And so you have here a report of the essential plots, the essential tables, and the essential results. And this is an HTML document that you can open up in any word processor and continue to edit and expand the report. This is all I wanted to show you in this complimentary video on how to operate the analysis wizard in the Omics skin. Thank you for watching.